How long would you like to be near Explorer 1? Yes, the ancient probe has done it once again and proven that, despite all the complexities, it is still a reliable station in the strange universe of interstellar space. This was preceded by an event that has almost become part of NASA's daily routine. The engineers had lost contact with Explorer 1 due to technical issues. And this was not the first time they had been forced to find effective fixes to restore communication with the aging spacecraft. Ultimately, the key to success lay in a component that had in fact been dormant for decades. The backup transmitter, which had not been used since 1981, worked as desired and allowed the space veteran to phone home again. When it's cold in space, when it's cold outside, it's a good idea to turn on the heating. So far, this seems obvious, but it gets a bit trickier when the temperatures in the depths of interstellar space need to be turned up, especially on a spacecraft that has been traveling through space for almost 50 years and has repeatedly drawn attention for its technical maladies. On October 16, NASA engineers issued a command to activate one of Explorer 1's heaters. To their dismay, 2 days later, they discovered that the Deep Space Network could no longer detect Explorer 1's signal. The reason for the delayed realization was the vast distance separating the probe and Earth. Since its launch in 1977, Explorer 1 has traveled approximately 24.7 billion kilometers away from our planet. Messages take nearly 23 hours to reach the spacecraft, with the same amount of time required for a response. What happened? Explorer 1 is equipped with an onboard error protection system that operates autonomously when issues arise. For instance, if the spacecraft's power supply becomes overloaded, the system automatically deactivates non-essential systems to conserve energy. Apparently, the heating command triggered this error protection system. Although Explorer 1 had sufficient energy to activate the heater, the system acted conservatively. To better understand this, it's important to note that Explorer 1 normally communicates with Earth through an X-band radio transmitter, named after its specific frequency. After losing contact, the engineers correctly deduced that the error protection system had reduced the transmitter's data rate to save energy. This was expected, as this mode consumes less power. However, it also alters the X-band signal, making it harder for the Deep Space Network to detect. Fortunately, on October 18, NASA engineers identified the faint X-band signal. Despite this success, a new issue quickly arose. A 40-year-old backup to the rescue. On October 19, communication with Explorer 1 broke down completely. The flight team suspected that the error protection system had switched off the X-band transmitter and instead activated a secondary radio transmitter, the S-band. This backup transmitter had been in technical retirement for decades. Although the S-band consumes less power than the X-band, it hadn't been used to communicate with Earth since 1981. A brief historical note: when Explorer 1 was last actively using the S-band transmitter, it had only just begun exploring Saturn and its moons. The year 1981 was also notable for events such as assassination attempts on U.S. President Ronald Reagan and Pope John Paul II, and the marriage of then Prince Charles to Diana Spencer. Back to the present. The S-band transmitter had been obsolete for decades despite its energy-saving advantages. This is because it operates on a different frequency from the X-band and produces a much weaker signal. Problematic given the vast distance between Explorer 1 and Earth. Initially, NASA engineers were unsure if they would even be able to detect the S-band signal. However, they successfully located it and began deliberating on their next steps. Given the error protection system's history, simply reactivating the X-band transmitter seemed too risky. This could only be attempted after thoroughly diagnosing the problem, which could take weeks or even months. Communication restored. Thankfully, contact with Explorer 1 was not lost during this time. On October 22, engineers sent a command to test the S-band transmitter's functionality. By October 24, they received a reassuring response. The transmitter was working, and communication had been restored. In a surprising twist, the S-band transmitter, unused for over 40 years, had come to the rescue. ensuring continued contact with humanity's most distant spacecraft. Despite the success of the S-band transmitter, it's clear that Explorer 1's journey to the edge of the solar system is now noticeably fraught with challenges. The Voyager mission's instruments have been negatively affected over time, and we may gradually, yet inevitably, have to face the reality that even the longest-running success story in space travel will eventually come to an end. However, the uplifting news is that the life of the Voyager probes is being extended, and the time for farewell has not yet come. That said, it's also true that the Voyager mission team sometimes needs to find creative fixes to prolong the operation of the spacecraft. These sister probes, identical in construction, have outlasted all expectations. When the Voyager spacecraft launched into the vastness of space in 1977, the anticipated mission duration was just 5 years. The fact that they have now exceeded this prediction by nearly 5 times is partly due to the strict power diet imposed to conserve energy from their aging radioactive core batteries. NASA has systematically powered down more and more of the spacecraft's instruments to ensure the remaining systems can operate for a few more years. For instance, Voyager 2's plasma sensor has been offline for several weeks now to supply energy to other instruments. However, this power-saving strategy is becoming increasingly precarious. If something unexpected occurs, like a critical thruster failing, the team will face significant challenges. The thruster issue. For the Voyager probes to point their antennas toward Earth and phone home in the best ET fashion, they rely on small thrusters for positioning. These thrusters, powered by liquid hydrazine, adjust orientation with bursts lasting a few milliseconds. Voyager 1 originally had 3 sets of these thrusters, but debris gradually accumulated in the fuel lines after decades in space. NASA switched to the second set of thrusters years ago, and finally transitioned to the third set, intended for course corrections, in 2018. Unfortunately, the third set recently became problematic due to clogging in the fuel lines. The situation is more serious this time. While the original course correction thrusters had a nozzle width of 0.25 millimeters, the remaining diameter is now only 0.035 millimeters, less than half the width of a human hair. Faced with this critical issue, NASA engineers decided to attempt switching back to one of the less worn thruster sets. A risky decision. Switching to the alternative thruster set was far from straightforward. Voyager 1 has very little energy left, despite extensive power-saving measures, and any additional power use could jeopardize vital systems. Moreover, to reactivate the alternate thrusters, they first needed to be preheated, which required shutting down another system to free up energy. But which system could be sacrificed? Each of the remaining systems is essential, and shutting one down carried the risk that it might not restart. NASA scientists spent weeks analyzing calculations and conducting tests. After thorough deliberation, they concluded that turning off one of Voyager 1's primary heating units posed the least risk. On August 27, NASA executed the high-stakes thruster switch maneuver. They powered down the main heating unit for 1 hour, allowing the alternate thrusters to warm up. The gamble paid off. Voyager 1 was able to reorient itself and resume communication with Earth. For now, the inevitable end. Despite this success, the alternate thruster set is also far from new and has a history of clogged pipes. At some point, no matter how ingenious the adjustments, the thrusters will fail entirely. Even if Voyager 1's antenna remains pointed at Earth, scientists predict that radio contact will be lost by 2036 at the latest, due to the spacecraft's ever-increasing distance from our planet. As we prepare for the eventual loss of communication, let us celebrate the incredible journey of the Voyager probes. Missions that far exceeded all expectations. Meanwhile, if you'd like to stay updated on such amazing stories, click the subscribe button so you never miss new updates. We'll see you soon.